everyone. I'm Samantha from SNS College of Technology, Department of Mathematics. In this lecture video series, Measures of Central Tendency, in this video we're going to see median. So first let us recall the previous topic, which is arithmetic mean. The arithmetic mean is an average of all the data, and here we can use the formula summation xi divided by n for the ungrouped data and summation fx divided by summation f for grouped data. So let us dive into the topic. So here in this video, we are going to see what is median, how to calculate median, and how to apply this concept of median in the problems. And we are going to compare the previous measure with the median. So first, let us see what is empathize. So the empathize part is why we have to use this median. Why do we need median? So, for example, consider a scenario where average income doesn't tell the full story. So, in a neighborhood with a 9 families of earnings of $50,000 and one billionaire, the mean income would be misleading. So, in this typical case, when we know the median, then we can judge that. So let us see what is median. So the median is also known as the middle value or the mid value in a data set where observations are arranged in either in a descending order or in an ascending order format. So it divides the distribution into two equal halves with 50 percentage values below and the 50 percentage values above. So the first step in median is to arrange the data in ascending order or in the descending order. Next, we have to find the mid position. If the numbers are, if the data are of even numbers, then we have to add the mid two values and divide it by 2. If it is an odd value, then we can take the central value. For example, if we have 7 values, then the fourth value will be the median. And if we have 8 values, then we will be adding the fourth value and fifth value and divide it by 2, which will give the median. Next is the identification of the value. Next, find part. So, how can we find a repetitive central value that is resistant to outliers and provide meaningful insight for a skewed distribution is the problem statement. Next is the key properties or it is not affected by extreme values, suitable for ordinal and numerical data. Next is unique for any data set and can be determined graphically. So here these are the two formulas to find the median. So the one is n plus 1 divided by 2 observation. Next is n by 2 plus n by 2 plus first value divided by 2. These are the two formulas for used to find the median of a ungrouped data in which odd and even numbers are given. So for the ungrouped data, if the odd values is given, for example, 23, 45, 12, 67, 34, 89, and 56. Here first we can arrange this in an ascending order format. So 12, 23, 34, 45, 56, 67, and 89. Then here the total number of values are 7. So n divided by 2. Sorry, here n plus 1 divided by 2. So here there are 7 data. So 7 plus 1 is 8. 8 by 2 is 4. So here the fourth value is 45. Therefore, the median value is 45. So here for the ungrouped even values, again we arrange it in the ascending order format. Here it is 8. So 8 by 2, which will be 79. The value is 4th and 5th position. So here for the grouped data, we have to find the lower boundary value. The median formula is L plus n by 2 minus CF divided by F into H, where this L stands for the lower boundary value and n stands for the total number of frequencies, that is the sum of all the frequencies. Next is CF. CF stands for cumulative frequency before the median class. We have to determine the median class using the previous formula. Next we have to find the frequency of the median class. Then the H. Here the H means the width of the interval, that is 10 to 20, 20 to 30, 30 to 40 means the 10 is the H value. So next is ideate part. So first we have to calculate the n by 2, next cumulative frequency, and if the CF is greater than n by 2, then we use the lower median class. So here this is the one of the form example of the grouped data in which the class height is 5, the frequencies and cumulative frequencies are given, and here the n is 50. So the first step is to find n by 2, which is 25, and the class, identify the median class. The class is 25 means it is 18. So it is 20 to 25, and L is 20, CF is 17, F is 18, and H is 5 from the previous table. So on applying all the values in the formula, L plus n by 2 minus CF divided by F into H. This is the formula for mean. On applying all the values in this formula, we will get the answer to be 22.22, which is the solution of the problem. So this is the prototype we can use in income analysis. So on applying, a company wants to understand typical employee salaries. So here is the monthly income distribution. So using the formula here, it will be given in the class intervals. So we use the formula, grouped data formula. So the answer is 42,000, which is the typical median salary of all the months. So in this, the mind map of this median is, first we have seen the what is a definition part, then grouped and ungrouped topic, next properties and applications. These are the some of the key takeaways of the median topic, which is a median and its definition. So the median is the middle value that divides the data set into two equal halves. Next is the calculation method, in which we have two types. One is grouped data and the one is ungrouped data. Next, the advantages, it is not affected by extreme value, and the practical application, we have seen a salary income analysis of a company. Thank you.